We often find ourselves trapped in a routine. Every day feels like the last, nothing happens, nothing changes. And truthfully, the space we each occupy, in both time and place, is so narrow that when we fail to use it effectively, very little actually happens. It feels the same on a cosmic scale, too. The sky has looked like this sky for thousands of years. Our planets, our sun, they've just been sitting there across the entire span of shared history. Ancient stories mention the same planets, the same stars, and that's accurate and convenient. We wouldn't exist in a more chaotic system anyway, but no matter how vast space looks from where we stand, we can still forget just how small our world is and how little space our solar system takes up on a cosmic scale. We've grown used to seeing it this way, and fairly so. But now, lean back for a moment, because right this second, we're going to talk about what's actually happening in the universe. While we go about our daily lives, a cascade of devastating, magnificent, mind-bending events is unfolding on a cosmic scale. And fair warning, so much happens in a single second that your head might spin. If you're ready, let's begin. Let's start with our own world. Earth is moving through space at 108,000 kilometers per hour along its orbit around the sun, which works out to roughly 30 kilometers every single second. Before 1 second is even up, our planet has already traveled 30 kilometers through the void. But it's not just Earth. Along with us, our sun and our entire solar system are orbiting the center of the Milky Way galaxy at 720,000 kilometers per hour. That's 200 kilometers per second, and that's not all. The Milky Way, together with the other galaxies in what we call the local group, is hurtling toward a gravitational focal point in the cosmic web known as the Great Attractor, at 1,000 kilometers per second. Meanwhile, Andromeda, another galaxy within that local group, is closing in on our galaxy at roughly 100 kilometers every second. We already know that in about 4.5 billion years, Andromeda and the Milky Way will collide and merge. So even though you might feel perfectly still right now, we're already thousands of kilometers into our cosmic journey, and the video has barely started. Now let's look at what's happening as that journey unfolds. Our sun is continuing to power our system and consuming itself to do so. Let's give it a moment of appreciation. You probably know how. Through a process called fusion, where hydrogen atoms are fused together to form helium. Every single second, the sun burns through 600 million tons of hydrogen, producing 596 million tons of helium. That missing 4 million tons? It's the energy, heat, and light that is the source of everything for us. And as part of this process, trillions of cosmic particles radiate from the sun and reach Earth every second. We're talking 10,000 to 20,000 cosmic ray particles per square meter. Without our atmosphere and magnetic field, that would be a lethal dose, enough to turn Earth into Mars. Shielded beneath that protective atmospheric layer, plants are producing 3,000 tons of oxygen every second. And all living things combined are consuming nearly the same amount. Every second, 16 million tons of water evaporate, and the same amount falls back as rain. We're inside a breathtaking cycle. But you probably know most of that already, so let's zoom back out to cosmic scales. Let's talk about stars. You know, those things that always seem so permanent, so unchanged. If we could travel back 11 billion years, we'd be greeted by a cosmic fireworks display. In that era of the universe, often called cosmic noon, so many stars were being born at any given moment that it was genuinely spectacular. Over time, that birth and death cycle peaked, and most of the matter filling the universe got locked away inside newly formed stars. Not much material was left to form new ones. That's why the rate of star formation today, compared to that cosmic noon, is only about 3 out of 100. Sounds low? Like the production line has nearly shut down. But what does that 3 out of 100 actually amount to? Right now, across the entire universe, 4,000 stars are born every single second. 4,000 just appeared. Now 8,000. Now 12,000. Can you imagine what that cosmic noon must have looked like? How many of those stars are being born in our neighborhood, in the Milky Way? 5, not per second. Per year. Take a moment to let the scale of that sink in. 4,000 stars per second across the universe, and our entire galaxy only manages 5 a year. Anyway, stars are born, and anything that's born must eventually reach its end. Stars die too in all kinds of ways. I've always found it more meaningful to think of stellar death as transformation. They become something else. Another star. Another form. Another object. Sometimes quietly, sometimes in spectacular fashion. The largest ones in particular go out with a supernova. As they near the end of their lives, when there's no fuel left and they've expanded to an unimaginable size, they collapse inward and blast most of their material out into the universe. In our current cosmic era, sometimes called the universe's youth, where second and third generation stars like our sun are still in their prime, these events are relatively rare. Across the entire observable universe, it's estimated that between 3 and 10 supernovae occur every second. So while 4,000 stars are being born each second, only about 10 are dying. The universe is still in a period of extraordinary production. Does that give you a little hope? You're in the right place then. Let's keep going and buckle up a little, because from here on, things push past the edge of what our intuitions can comfortably handle. We're arriving at the universe itself. Here's the well-known part. The universe is expanding. The expansion that began with the Big Bang never stopped. In a sense, we're still inside the Big Bang. It's an ongoing process. But here's where the first strangeness comes in. Think about an explosion, a bomb going off. It creates pressure waves, heat, sound. And what does the physics we experience every day tell us? Those waves weaken over time and eventually stop. That's not just likely, it's certain. An explosion's effects can't go on forever. And it would be even more absurd to suggest that the explosion speeds up at some point, right? And yet, the universe is expanding. By that same logic, you'd expect it to slow down and eventually stop. But a few billion years ago, something happened. We don't know what. But something happened, and the rate of expansion suddenly started accelerating. We called the cause dark energy, something that emerged from the very fabric of the expanding universe. A force. A power. And under its influence, the universe is now expanding at 7.2 billion kilometers per hour. But wait, there's a problem. Do you know what 7.2 billion kilometers per hour actually means? It means 2 million kilometers per second. And we know the speed of light, 300,000 kilometers per second. So how is the universe expanding at nearly 7 times the speed of light? Wasn't the speed of light the ultimate speed limit, the hard boundary of known physics? Here's the thing. Our constants, our laws, apply to us, to beings living inside the universe. The universe itself has no obligation to follow those rules. And yes, while we've been saying all of this, the universe has expanded by millions more kilometers, breaking every rule on its way to new horizons, and it will keep going. If you're wondering what else is happening, let's go a little deeper. The universe is expanding, stars are being born, our sun keeps burning through its fuel. And in the middle of all that, what else is going on? For one thing, the Big Bang is still echoing. About 380,000 years after the Big Bang, photons were released, and the cosmic microwave background radiation keeps producing them to this day. Right now, this very second, trillions of those photons are passing through your body. We are still immersed in the oldest light in the universe. The light of the Big Bang is still illuminating us. But it's not all beautiful. Disorder is also increasing. Entropy. Entropy keeps rising, keeps growing stronger. Black holes are among the chief culprits. When something falls into a black hole, everything about it, its structure, its order, its history, becomes indistinguishable from the outside. Information is lost. And as information is lost, the number of things we can distinguish about the system decreases. The number of possible states increases, and entropy rises. What this means? The universe is slowly moving toward a state that is more disordered, more irreversible, where reconstructing the past becomes impossible. There are approximately 10 to the power of 22 black holes in the observable universe, and every second, total entropy increases by roughly 10 to the power of 80 to 10 to the power of 90 units. Thanks to, or because of, those black holes, we are losing staggering amounts of information every single moment, irreversibly. All right, we've been talking about what happens in 1 second, but we've probably been at this for about 10 minutes now. What happened in those 10 minutes? Let's scale it up. In 10 minutes, 600 seconds While we sat here talking, Earth traveled roughly 18,000 kilometers around the Sun. Our solar system moved 120,000 kilometers through the Milky Way. Our galaxy crept 600,000 kilometers closer to the Great Attractor. Andromeda closed 60,000 kilometers more of the gap between us. Our Sun converted approximately 360 billion tons of hydrogen into helium. Combined with the cosmic rays reaching Earth every second, a total of 10 to the 21st power particles struck our atmosphere. Plants produced 1.8 million tons of oxygen, all of it consumed. 9.6 billion tons of water evaporated and fell again as rain. On the cosmic scale, approximately 2.4 million new stars were born. Between 1,800 and 6,000 stars completed their lives. Thousands of planets continued growing through their formation, and the universe itself expanded by roughly 1.2 billion kilometers. In just 10 minutes of conversation, our solar system, our galaxy, and the universe as a whole underwent transformation on an incomprehensible scale. And while all of that was happening out there, what was going on in our backyard, right here on Earth? What turned inside the machinery of the remarkable thing we call life? Right now, this very second, 4 to 5 people were born, and 2 said goodbye to life. Hundreds of millions of living beings were killed and consumed by other living beings. Death on one side, fuel for life on the other. But perhaps most heartbreaking of all, it's estimated that 100 to 200 species go extinct every single day. They are being erased from the face of the Earth. While we've been talking, another species reached its end, and yet at the same moment, millions of new genetic mutations occurred. Life was shrinking on one side and rewriting itself on the other. But to sum it all up, in those ordinary moments when we feel like nothing is happening, we are inside a system moving at unimaginable speed, constantly changing, constantly transforming. While we think we're standing still, we're traveling kilometers through space. While we say nothing is changing, millions of stars are being born and thousands are dying. The universe looks silent, but every second it's expanding, vibrating, breaking apart, or rebuilding itself. And this story keeps being written at every moment, completely indifferent to our daily worries. Maybe that's why studying cosmology, trying to understand the universe, makes you feel both tiny and insignificant, and yet gives you a completely new sense of understanding. We are an inseparable part of an enormous system at every scale. And thinking about that, I don't know about you, but it brings me a deep sense of peace. And as always, until next time, I'm glad you exist. With love.